Professor Blatt, dear colleagues, ladies and gentlemen, thanks for the invitation and your words of welcome. Talking to physicists is not my everyday work, so let us see what I could offer. The question about knowledge is, and ever was, also the question about what we do not know. Where there is knowledge, there's also ignorance. Ignorance thrives on knowledge, thrives on research. That is, in a sense, trivial. If there were nothing we did not know, knowledge, that is, the search for knowledge, would lose its sense. Even the distinction between knowledge and ignorance could not be made. Likewise, the question whether there are limitations of knowledge and limits of science, the topic of my paper, could not be asked. Let me start with a few general remarks about knowing and not knowing, about limits of knowledge. We all are conscious of our intellectual limits, both in private and professional affairs. That is, conscious of what we do not know and probably never will. Brains, it seems, have only a finite capacity to absorb, and life is short, and for that reason alone unsuited to dreams of limitless knowledge. What is this peculiar feeling of confronting limits of knowledge, which, unlike political and geographic boundaries, are apparently not easy to cross? Is the occasional individual displeasure at knowing too little in the end the expression of a universal human incapacity, namely the incapacity to know everything, that is, to comprehend everything that exists in scientific form or even in non-scientific form? Thinking this way already makes you half a philosopher. Indeed, from the beginning, it has been one of the favorite occupations of knowledge, of philosophy, not only to ask about the conditions of origin of knowledge, how knowledge arises, what it presupposes, and about the essence of knowledge, what distinguishes knowledge from opinion, for instance, but also about the limits of knowledge. Normally, this meant limits of knowledge in the sense that the capacity and organization of the human understanding is simply not sufficient to answer all the questions that can be posed, nor to explore everything that can in any way be thought to be explorable. Human understanding is conceived as something like a lamp or searchlight. Knowledge reaches as far as its beam of light. Beyond the reach of the beam lies darkness. Knowledge, so to speak, limits itself because the understanding is limited in its reach. And where it gropes about without light, it is blind. It fails to grasp its object and must abandon the fields to others, mystics, esoterics, dreamers, all of them equipped with supposedly superhuman abilities. But these are not the limits that I want to talk about. Nor do I mean the limits of speculative or speculating knowledge, but rather the limits that really, or perhaps only apparently, arise for our scientific understanding. Indeed, the limits of knowledge are not only a theme for the everyday understanding or for philosophy, but also for science itself. At least, now as reflection on the limits of science, at the point where science begins to become philosophical, that is, to view itself with philosophical eyes. This does not happen often, but it does occasionally happen. My paper has 4 parts. First, I shall pursue the question whether science is completable. Second, I shall adduce arguments for its incompletability. Thirdly, I shall consider factual and ethical limits. And finally, I shall argue for practical but against theoretical limits. My first point, completed science, question mark. My introductory remark, philosophy talking about limits of knowledge, may have sounded rather negative, or at least regretful, as if we were obliged to submit to the inevitable. As a matter of fact, wherever we speak of the limits of knowledge, we become small as a rule. We experience our own limits. We draw anew the boundaries between the human situation and the divine. In the Middle Ages, the limits of knowledge were always boundaries between the knowledge-seeking human and an omniscient God. Where the philosopher stopped, there the theologian began. And where he got stuck, there frolicked the mystics. Even Faust, as we know, did not get much farther, and not just because of Gretchen. Opposed to these notions of the limits of knowledge, nourished by negative experiences or too far-reaching reveries, there is a quite different notion that is even very positive, namely the notion of a completion, or at least completability of knowledge. Limits of knowledge. That could also mean that knowledge comes to a standstill when all is known. When the world has given the human understanding knowledge of all that there is to know. When all corners have been searched, all riddles solved, all problems cracked, all Gordian knots cut, and all things that seem impossible are provided with acts of Columbus. Limits would lose their intimidation or their disappointment. They testify not to the failure of human understanding, but rather to its triumph. As a matter of fact, the history of science is full of expectations, prophecies, and assurances in this direction. I want to present a few examples. In 1754, Denis Diderot, along with the mathematician d'Alembert, editor of the great French Encyclopedia, wrote, I quote, "I can almost assure you that in Europe within the next century we shall not count 3 great mathematicians. The science will stand quite still, where it was left by the Bernoullis, Euler, Maupertuis, Clairaut, Fontaine, and d'Alembert. They have erected the pillars of Hercules. We shall not pass beyond them. Their works will continue through the centuries to come just like the Egyptian pyramids, whose stones covered with hieroglyphics invoke in us an awful idea of the power and resources of the man who erected them." Unquote. Mathematics and physics, the names listed stand for both, may come to be completed. Science, like the pyramids, would become a grand exhibition piece visited by science tourists without a scientific future of their own. American physicists in the 1970s expressed similar thoughts to the National Academy of Sciences. I quote again, "It is possible to think of fundamental physics as eventually becoming complete. There's only one universe to investigate, and physics, unlike mathematics, cannot be indefinitely spun out purely by inventions of the mind. The logical relation of physics to chemistry and the other sciences it underlies is such that physics should be the first chapter to be completed. Some unsolved problems might remain in the domain earlier characterized as organized complexity, but these would become the responsibility of the biophysicist and the astrophysicist. Basic physics would be complete. Not only that, it would be manifestly complete, rather like the present state of Euclidean geometry." Unquote. In the same vein, the physicist David Lindley in 1994 spoke about the end of physics, albeit with reference to the problem of a transformation of physics into a sort of la pour la mathematics. And Steven Weinberg says much the same. Quote, "My belief in a final theory rests on the fact that our picture of nature has become ever more simple. Of course, the mathematics has become more complicated, more difficult, more abstract. But the physical principles have become more elegant, more natural, and above all, there are fewer of them. And progress in the direction of simplicity must come to an end at some point." Unquote. In this opinion, too, it is clear that the end of science is not the expression of incapacity in the sense of limits given to or forced upon human understanding. Rather, it can also be the expression of the achievement of the human understanding, indeed, of its triumph about nature. Such limits of knowledge are filled out boundaries. Beyond these boundaries lies nothing that could be of scientific interest or which could present new tasks for science. Once nature is discovered, once nature's laws are recognized and codified in textbooks, once everything has become simple, in Weinberg's sense, there's nothing more to discover and knowledge comes to a standstill. It can no longer be disappointed and replaced by better knowledge. It is no longer on the agenda of human understanding. The extent to which such notions have gained currency was made clear by John Horgan, former editor of Scientific American, whose book, The End of Science, roughly 20 years ago, created a furor. According to Horgan, the end of science is near in the sense that its success is his own end. According to him, all great discoveries have been made and all great theories written, all scientific questions answered. What remains is only scientific mopping up, calculating decimal places or didactic variations on a theme that can no longer be changed anymore. Science, in other words, is complete. And the human understanding has to look for new tasks or challenges beyond science. A peculiar notion. My second point, the sphere of knowledge. To the picture of a completed science, whose boundaries would be the boundaries of an impressive empire, we can oppose a different picture. It is a picture of a science that perhaps does not accord with the fantasies of the philosophers of science, but it does accord rather well with the reality of science. This reality, known to every scientist, tells us that for every scientific problem that is solved, new problems arise. That for every question answered, new questions are posed. That for every insight gained, a new ignorance is revealed. And that this ignorance does not merely refer to further decimal places is a very common experience of daily scientific work. We are dealing with questions like, how does a single cell develop into a complete organism? How did the galaxies arise? How did the whole universe arise? What goes on in black holes? What is, between philosophy and neuroscience, consciousness? One question succeeds the other, and all of them are far from answered. We can visualize the problem in a picture that takes up a metaphor already used in a very other context by the philosopher and mathematician Blaise Pascal. Scientific knowledge is a sphere floating in a space of ignorance and growing ever larger. As the sphere grows, its outer surface grows too, and thus the surface of contact with ignorance grows. This picture, which sees no limit to knowledge, can be interpreted in two different ways: a pessimistic version and an optimistic version. The pessimistic interpretation says, if it is the radius of the sphere that represents knowledge, then as the sphere increases in size, the area of the surface increases faster than the length of the radius, namely as the second power. Thus, ignorance grows faster than knowledge. Or in other words, scientific research produces a faster growth of ignorance than of knowledge. This is a startling, but at least with regard to the elementary mathematics involved, correct result. In the optimistic version, it is not the radius of the sphere that represents knowledge, but its volume. As the sphere grows, its volume grows faster than its surface, namely as the third power of the radius. In this case, research, scientific research, still produces ever more ignorance, but knowledge is growing faster than ignorance. Whichever interpretation of this sphere of knowledge one chooses, one thing is clear in this picture, and probably also in the experience of those scientists who do not deal immediately with the grand theories of their disciplines or with the grand design of all knowledge. The growth of knowledge does not make the world of the unknown, of the not yet explored, any smaller, but rather larger. Research tasks grow with knowledge, with growing knowledge. There is no limit to the unknown. Rather, it is the proximity the constant contact to the unknown, sometimes not only in the minds of philosophically minded scientists, the scent of the unthinkable or unimaginable, or what is taken to be so, that keeps science under its spell, that constitutes its stamina, even where what is already known seeks to present itself as knowledge on the brink of completion, or seems to be unreachable with the available means, or even seems to be inaccessible in principle for epistemological reasons. Here the limits are really dissolved, and knowledge, scientific knowledge, presents itself as essentially limitless. Neither are there boundaries with which the scientific understanding collides and gets a bloody nose, nor are there boundaries that form the contours of something completed. Is then the answer to the question, are there limits to scientific knowledge, a simple no? My third point, limits of science. Whoever gives a negative answer to the question as to the limits of scientific knowledge draws not only the vehement opposition of the proponents of the finiteness thesis, the realm of the scientifically knowledgeable is finite, therefore knowledge itself is finite. He also opposes, in a certain sense, the everyday understanding and the philosophical understanding as well. For the everyday understanding, the existence of limits is something completely normal. Luck has its limits. Skill in any area is limited by lack of skill at some point. Alongside fulfilled wishes, there are also unfulfilled ones. For the philosophical understanding, the existence of limits is something quite plausible and even alluring. Where there are no limits, there is no reflection, no deep contemplation of limits, and in such reflection and in such contemplation, the philosophical understanding is particularly strong. Historians of science see this too, inasmuch as they connect science with scientific progress. In a book on the idea of progress from 1932, we read, I quote, "Science has been advancing without interruption during the last 300 or 400 years. Every new discovery has led to new problems and new methods of solution, and opened up new fields for explanation. Hitherto, men of science have not been compelled to halt. They have always found means to advance further. But what assurance have we that they will not one day come up against impassable barriers? The existence of 400 years in which the surface of nature has been successfully tapped can hardly be said to warrant conclusions as to the prospect of operations extending over 400 or 4,000 centuries. Take biology, still quoting, take biology or astronomy. How can we be sure that someday progress may not come to a dead pause, not because knowledge is exhausted, but because our resources for investigation are exhausted? Because, for instance, scientific instruments have reached the limit of perfection, beyond which it is demonstrably impossible to improve them, or because, in the case of astronomy, we come into the presence of forces of which, unlike gravitation, we have no terrestrial experience." Unquote. Here, limits in the negative sense appear, limits as unwanted limitations on knowledge. on scientific knowledge. Philosophy of science discusses these questions mainly in relation to the natural science in the form of two theses. First, the thesis of the complete or asymptotic exhaustive survey of nature. This accords with the thesis of finiteness if we understand finiteness as completion. According to this thesis, the history of scientific discoveries is either absolutely finite or at some point enters into an asymptotic approach to what could be known at all. The place of innovation would be then taken by mere elaboration and further precision. At some point, science would have no future anymore, because, again, everything discoverable would have been discovered and everything would have been explained that was in need of a scientific explanation. And even the mopping up operation, the calculation of further decimal places, the classification of additional cases that add nothing essentially new, would gradually come to a close. The second thesis is the thesis of the complete or asymptotic exhaustion of information capacities. Not of nature, that was the first thesis, but of information capacities. This is a thesis that our historian of science propounded. According to this scenario, scientific information capacities are either absolutely finite or at some point enter into an asymptotic approach to absolute information limits. Here, too, elaboration and further precision would replace innovation. Science would have exhausted its own possibilities for research, and articulation and an information barrier would arise between science and nature, irrespective of whether investigation of the latter had reached a point of exhaustion. To overcome this barrier, we must turn to science fiction, traveling with Star Trek and the spaceship Enterprise off into scientific wonderland. The question, does scientific progress still have a future, is thus only an apparent paradox. The question is, however, in fact, unanswerable within the framework of the cited thesis. This is evident even without invoking, once again, the picture of the sphere of knowledge from the connection between our research activity and our goals. If research is characterized not only by means of the states of research, which have been achieved within individual disciplines, say with regard to answering scientific questions, but also by means of the internal and external purposes associated with it, and this is doubtless the case as a comparison of Newtonian physics with Aristotelian physics, each of which pursues completely different purposes, makes clear, then the notion of an end to scientific progress would include not only the assertion we know everything, what we can know, but also the assertion we know all the purposes that we can have. The number of purposes, however, is unlimited, even if we take into account the limits to a scientific transformation of the world and of humankind. In other words, in order to answer the question, does scientific progress still have a future, we would in some way already have to know what we do not know yet, what only progress or its failure to materialize could show us. In this sense, then, there are no limits to science. This applies also to the question of whether our sphere of knowledge rolls finitely or infinitely onward. There is one thing that we can nonetheless know. The resources are finite. They are long since insufficient to provide science with what it needs in light of its growth and its wealth of ideas. There is also reason to believe that the higher the state of research is reached, the more means must be applied to make equivalent advances. At one time, a few silver coins were enough to move the world, even the scientific world. Today, it takes a large percentage of the gross national product of a country. Think of the construction and running of large particle accelerators in physics that devours huge sums in order to isolate one single further building block of the universe, or to add further decimal places to measurements that are considered significant, or to confirm experimentally some constants of nature. Thus, the discovery of the top quark, the last of the quarks according to the standard model of particle physics, demanded the employment of a group of 450 scientists from 35 institutions for about 20 years and devoured thousands of millions of dollars. The question of marginal utility may be posed in science too. However, propositions and judgments of this kind depend not unproblematically on a qualitative and quantitative evaluation of innovation, scientific innovation. In the last analysis, it is not the mass of scientific production, but the quality that counts. In any case, it is true that progress limits itself if the costs grow faster than its results. There are other limits that can be added, for instance, ethical limits. Such limits to scientific progress become evident today, especially in the area of reproductive medicine and genetic engineering. The question is whether, driven forward by scientific progress, we are also allowed to do everything that we are able to do. For instance, intervening in the germline of humans or cloning humans. Ethical limits to scientific and technological progress generally are drawn wherever these, instead of improving the living conditions of humans, turn against us, threatening and deforming us. A threat to or deformation of humans exists wherever humans are seen only as means, not as persons. Wherever, speaking with the German Constitution, the inviolability of the dignity of man is no longer guaranteed. Max Born remembered, I quote him, "In my youth, it was still possible to be a scientist without paying much attention to the practical applications of science and in technology. Today, this is no longer possible, for natural science is inextricably entangled with social and political life. Nowadays, every scientist is a member of the technical and industrial system in which he lives. Therefore, he must also carry part of the responsibility for a rational use of its results. Albert Einstein was somewhat more skeptical on this score in 1948. Quote, "The tragedy of modern man lies in the fact that he has created conditions of existence for himself for which he is unprepared by his phylogenetic development." What he means, what Einstein means, is that the impulses of the brain stem are stronger than the controls of the cerebrum. In contrast to the usually rather philosophic question of the limits of knowledge, the question of the limits of scientific knowledge in particular cases is concrete. And thus, in the sense of real limits, it is also answerable. In the case of economic limits, we are dealing with factual limits. There's not enough money. In the case of ethical limits, we are dealing with normative limits. The obligatory and the permitted limit the possible. The fact that questions of economic and ethical limits are not always easy to answer depends on the fact that, in the case of economic limits, decisions as to priorities have to be made, and in the case of ethical limits, we encounter a mixture of science and worldview. Humans are not perfect beings, neither in regard to epistemology nor with regard to economics and ethics. A current but also difficult example of the question of ethical limits is the debate about cloning, in particular about the possible production of human clones, reproductive cloning. The new potential of genetic technology has suddenly made possible something that once seemed to be forever beyond the horizons of human intervention, namely the fabrication of a human being. It seems that boundaries drawn by nature itself are disappearing. Producing clones means producing living creatures with the same genetic information, either by exchanging cell nuclei or by dividing embryos at very early stages of development. Cloning thus means that the genotype, that is the primary hereditary material of two or more individuals, is the same, which does not mean that their phenotypes, the aggregate of external traits resulting from the genotype, are identical. Not all traits of an organism are wholly determined by the effects of the genes. The developmental conditions of an organism, including, in the case of humans, social and cultural conditions, also play an important role. In the case of identical twins, this has long been known. This makes it clear, by the way, that the production of clones is a thoroughly natural process. It is a replication mechanism that is quite common in nature, for instance, in bacteria and other microorganisms. What is new is only that this method can now be artificially applied to higher vertebrates. And what is of ethical significance is whether this kind of procedure may permissibly be applied to humans. Now, it should first of all be recognized that there is an infringement of human dignity neither in the identity of the genomes of two people. Identical twins are individual persons and bearers of human dignity, nor in the procedure of cloning itself. In this procedure, no person yet exists whose dignity could be attacked. On the contrary, an infringement of human dignity occurs only through the fact that a human being is produced as a means to an end that is not he himself, and that to this purpose genetic identity with another human being is imposed on him. This would be the case, for instance, in cloning for the purpose of producing donor organs or tissue, that is, establishing an individual organ bank. But this notion, the clone as a storehouse for spare parts, is absurd, since the clone, just as a natural twin, is of course an individual with all the rights that we associate with individuals. The fact that one, the clone, is just like the other, the cloned, is a circumstance that we have long been accustomed to in identical twins, whereby no one imagines that the one is only there for the other. Thus it is clear that whatever apparently powerful arguments have been pulled out of the arsenal of philosophers and theologians, cloning itself is not in any sense in itself reprehensible, but only in connection to particular human intentions. However, the question of principle remains. How much technology do we want to place in the stead of traditional modes of behavior that are considered natural? After all, with the technology of cloning, we change not only future generations, but also change ourselves, at least in our self-understandings. In other words, wherever boundaries are crossed, which, as in the case of human reproduction, seems to be set by nature, we must analyze very precisely and without recourse to individual intuitions or to ideological prejudices, just where such boundaries ought to lie in the future. For man is a being without measure that can only live by means of measures. To find these measures and thus to set the right limits is difficult even when, as in the case of our example, they seem clear to many people for whatever reasons. My last point, productive incompleteness. If the reflections that I have presented here are correct, then the question, are there limits to knowledge, formulated here as the question, are there limits to science, can actually be answered in the ethical and economic sense with a clear yes. Though in the ethical case, this is not always easy. And in the epistemological case, with just a clear no, possibly limited by the consideration that only the progress of science itself or its failure to progress can really show whether the scientific understanding in fact has internal or external limits. This answer is confirmed by epistemological efforts concerned with demonstrating demonstrating epistemic finiteness. For example, in discussions concerning the boundaries of science and the limits of our knowledge, reference is often made to Gödel's incompleteness proof, to undecidable theorems, and to Heisenberg's so-called uncertainty principle. Heisenberg's principle, in opposition to classical physics, states, as you know, that there are quantum theoretical laws according to which arbitrarily precise and simultaneous measurements of certain states of a system are impossible. More precisely, of canonically conjugated magnitudes, for instance, the position and momentum of a particle. Thus, we have here a law-like limit on the boundaries of the precision measurement of certain physical magnitudes. On the other hand, according to Gödel's theorem, there is in each consistent logical system strong enough to permit the construction of arithmetic at least one sentence which is true but which cannot be derived within the system. Furthermore, the assumed consistency of the system cannot be demonstrated by the means provided by the system itself, taken some natural constraints as granted. Gödel's theorem thus points not only to boundaries on that which can effectively be achieved, but also to an unexpected distinction between truth and derivability. The same holds in the case of the related undecidability theorems, according to which a sentence A is indecidable if there is no general finite algorithm that is neither a semantic nor a constructive algorithm, according to which it can be decided whether A is true or not. These proofs thereby set bounds on effective procedures. Now, in all of these cases, that is, in the incompleteness and undecidability theorems of logic and mathematics, as well as in the so-called uncertainty principle of physics, we have affair less with the limits to science or with limitations of our knowledge than with the results of the scientific construction of knowledge. More precisely, we are dealing with scientific results concerning the limitation of the knowable insofar as the latter is based on effective procedures. That is to say, theorems such as those of incompleteness or of undecidability do not set limits to knowledge in the conventional case. They are instead part of logical and metamathematical knowledge. And thus they cannot be used against this knowledge. By which I mean here, they cannot be employed as arguments against the power or capacity of this knowledge. Besides, scientific thought is, so to speak, constantly reinventing itself, realizing itself in its constructions and destroying itself with its constructions. The phoenix is the symbol of science, just as the owl is the symbol of philosophy. Science creates itself, just as philosophy considers itself and what it has seen. Science thrives on the mortality of knowledge, philosophy on the immortality, or better, limitlessness of reflection, which therefore constantly encounters itself, while science forgets and discovers. Only the concept of construction holds the two, philosophy and science, together. For philosophical reflection too, so long as it does not just reproduce itself hermeneutically, constructs, devises new worlds only to fill them again with its age-old experiences. Well, those who find these statements too philosophical may prefer the more modest formulation, which is, however, equivalent in content, that scientific knowledge must, as a rule, be taken to be imperfect or incomplete and incorrect, though not in the sense of a defect. Such a notion would in fact presuppose an attainable perfection or completeness, but in the sense of an openness of scientific knowledge in principle. Furthermore, paradoxically formulated, the boundlessness of science, in the sense of an interminable progress of knowledge, lies precisely in the limited character of knowledge, in its finiteness and corrigibility. Here I would like once more to invoke the sphere of knowledge. It floats in a space of ignorance and grows ever larger, thus increasing its surface of contact with ignorance. Or in another formulation, the limits of science are either error limits. The scientific understanding gets stuck in its own insufficiency, or economic limits. Scientific progress becomes unaffordable, or moral or ethical limits, which are ever more often given in cases where scientific progress is directed against humankind itself. In any case, any standard or measure of science, also that which sets limits to its progress in the realm of economics or ethics, is a practical one, not a theoretical one. Errors turn out to be normal. Resources turn out to be finite. Norms, ethical norms, turn out to be compelling, although this is not due to any unsurmountable properties of the knowable or of the knowing subject's understanding. This means, and this is my last point, my last sentence, this means that science does indeed have practical limits, but no theoretical limits. And this, if you like, equates the human and the divine in science. Thank you.